When it comes to the mysteries of the universe, there are far too many to count, but among all the chaos, one fact remains. Everything we know will one day come to an end. The cycle of life and death is an undisputed part of nature that no one can run from, be it a mere cellular organism found in the depths of the Earth or an entire galaxy teeming with countless stars and planets. With this in mind, we must ask ourselves, what could turn an entire galaxy into a lifeless husk? And could the same destructive fates await the Milky Way? The universe contains billions of galaxies, of which our own Milky Way is just one. Often thought of as a vast agglomeration of stars, which is how they look in photographs, galaxies contain other types of material as well, such as gas, dust, and dark matter. Astronomers know that galaxies began to form soon after the Big Bang, but they don't yet fully understand the process by which they ended up as we see them today. Evidence suggests that the birth of a galaxy is a violent event in its own right. As the universe expanded in size following the Big Bang, all the matter in it was spread out more and more thinly. At the same time, there was a competing effect, the force of gravity, that was pulling this generally diffusing matter into denser clumps. Some of the clumps were just transient affairs that eventually dissipated, but in other cases the clump's gravity was strong enough to pull in more matter and allow it to grow. As the mass of the clump increased, so did its gravitational pull, causing it to violently collapse down to a smaller size and higher density. In this way, the first proto-galaxies were able to form within the first few 100,000 years of the universe's existence. While astronomers agree this is how the first galaxies formed, the events that followed are up for debate. Essentially, there are two competing theories called top-down and bottom-up. The top-down theory, dating from 1962, came first. According to this theory, the first clumps to collapse took the form of giant gas clouds which were comparable in total mass to present-day galaxies. As the gas collapsed and its density increased, some stars formed very early on before the gas had stabilized into a rotating disk. These early stars formed the elliptical or bulge-like component of a galaxy, while later stars formed inside the much thinner disk component. The bottom-up theory, also known as the hierarchical clustering model, is more recent and generally considered a better match with current observational evidence. It introduces two new factors that didn't play a major role in the top-down model: dark matter and galactic mergers. We know that dark matter must exist in galaxies because of its effect on their rotation rates, and it seems likely that it played a key part in the original formation of galaxies. But the bottom-up theory, unlike the top-down theory, doesn't assume that the original proto-galaxies must have been the same size as present-day ones. Instead, it takes the view that they were much smaller, and it was only later on that they grew to their present size through repeated mergers. But what if the very dark matter which helped create these galaxies was responsible for their eventual downfall? Could this mysterious substance be the galactic killer scientists are searching for? A group of astronomers in Western Australia has stumbled across a murder mystery of cosmic proportions. A recent survey of thousands of far-off galaxies revealed that a process that suddenly strips these massive celestial objects of their gas is far more common than scientists once thought, and it's unclear what exactly is causing it. According to astronomer Michael Lamb, the life cycle of a galaxy is not well defined, but generally goes something like this. Enormous masses of cosmic gas and particles coalesce over long periods of time, creating billions of stars in the process. Once all that free-floating gas is used up, no more new stars can be created, and that galaxy is considered dead. Considering the massive timescale that these cosmic processes operate on, this can take billions or trillions of years. Galaxies, however, don't always get to live out their natural lifespans. Astronomers at the International Centre for Radio Astronomy Research, ICRA, in Western Australia, recently conducted a survey of about 11,000 galaxies, discovering that a phenomenon whereby galaxies' free gases are suddenly stripped away is far more common than scientists once thought. This process is a swift death for galaxies, rendering them incapable of creating new stars. While it's still unclear exactly what causes this process, a new study names dark matter halos as the likely culprit. A dark matter halo is a hypothetical region that has decoupled from the cosmic expansion of a galaxy and contains gravitationally bound matter. As galaxies drift through space, they stand a chance of coming in contact with these nebulous zones, which can suddenly and violently force all the galaxy's free gas to dissipate. Toby Brown, an ICRA astronomer and leader of the study, states that galaxies can inhabit halos of different sizes during their lifetimes, ranging from masses typical of our own Milky Way to halos thousands of times more massive. As galaxies fall through these larger halos, the superheated intergalactic plasma between them removes their gases in a fast-acting process called ram pressure stripping. While scientists have yet to directly observe dark matter, its existence is often inferred by examining odd gravitational effects that occur around galaxies and influence their movement. Only recently, astronomers discovered an ominous ring of dark matter halo around our very own Milky Way. The Milky Way's dark halo is believed to outweigh the galaxy's normal matter by a factor of 20. While the inner edge of the luminous hypothesized outer ring that surrounds the spiral disk of the Milky Way may be around 120,000 light-years across, the dark halo encompasses and permeates even the enormous luminous ring of scattered individual stars and globular clusters, extending some 300,000 to 400,000 light-years out from the galactic center in radius. A team of scientists, which includes Jörg Demand, Michael Coulin and Piero Maddow, modelled the process by which dark matter clouds are attracted to form the Milky Way's dark halo. They simulated the development and movement of 234 million cloudlets as they come together to form a dark halo about the same size as that around the Milky Way. Their simulations show that there should be at least 10,000 separate subhalos of dark matter within the overall galactic halo, each at least a few thousand light-years across. Over time, a fair number of these galactic seeds should have attracted ordinary matter to form star clusters. About 120 of the larger clumps of dark matter should have become large enough to have attracted enough gas to become dwarf galaxies, although astronomers have identified about 15 dwarf satellite galaxies around the Milky Way thus far. Astronomers have detected evidence that these dwarf satellite galaxies are disturbing the cocoon of dark matter around the Milky Way and causing its disk to warp. In 1957, astronomers surveying galactic hydrogen gas discovered that the Milky Way is not flat but warped near its edges like a fedora hat, with one side of its spiral disk curving as much as 20,000 light-years above the main galactic plane, and the other dipping a little less below it. While some researchers suspected the warp was caused by the two nearby satellite galaxies that orbit the Milky Way every 1.5 billion years, subsequent calculations showed they alone were not massive enough to produce the disk's warp. This could indicate that the Milky Way has collided with a dark matter halo and is falling victim to ram pressure stripping. If this is indeed the case, the Milky Way could eventually be stripped of its gases, resulting in a destructive chain reaction that would cause the galaxy to suddenly collapse. But what does this mean for life on Earth? Does the fate of our species depend on a cosmic fluke? Death is little more than a foregone conclusion for all matter, but an ever-expanding universe always tends to put our seemingly inconsequential lives into perspective. For instance, by the time the Milky Way winks out of existence, it may erase all evidence of humanity with it. In the cosmos, the physics involved in death and dying is a little more subjective than it is here on Earth. For instance, when the sun begins the process of sputtering out, the star will redden and swell up to more than 100 times its current size. In its final throes, the star will devour the inner planets, leaving Earth to either burn up with it or freeze over from the cold abyss without a star to keep it warm. Continuing the theme of cosmic devastation, some have predicted that the galaxy as we know it will disappear in another 5 billion years or so, when the Milky Way collides with neighbouring Andromeda galaxy, 2.5 million light-years away, to form one mega entity. But similarly to how bones can persist years after humans and animals meet their demise, our slice of the cosmos will leave behind a corpse of its own. Though it will be billions of years before such a fate becomes reality, a new study published in the journal Monthly Notices of the Royal Astronomical Society details where stars in our beloved Milky Way will end up: the galactic underworld. Essentially a graveyard, this celestial Tartarus is a home to a ghostly distribution of dead neutron stars and black holes that were formed when exploding supernovae exhausted the life cycles of what were once massive suns. Though invisible to the naked eye, astronomers use digital simulations as well as their knowledge of galactic history to model ancient stellar distributions, paving the way to chart the first map of the Milky Way's final resting place. Peering past the veil, what they found was certainly surprising. While this galactic cemetery only contains about 1% of our galaxy's overall mass, it exhibits a vastly different distribution and structure than its visible counterpart. This means that, unlike a true shadow, they are perfectly in line with each other, and their structures look much different when viewed at different angles. Strangely enough, this cemetery is much bigger than its living twin. In fact, it's so large, it far exceeds that of our own Milky Way. It's natural to ask when exactly the death of the Milky Way is due. According to Peter Tuthill, co-author of the study and professor of astronomy at the University of Sydney, whether or not our galaxy has an expiration date humans can foresee, it's hard to say. But the Milky Way isn't exactly a spring chicken anymore. Tuthill states that the golden age of the universe is behind us. The galaxy we're in today is past what astronomers think of as the big epochs of star formation. Though it's still forming new stars, the rate at which they're spawning is steadily decreasing, a sure sign that we may slowly but surely be on our way out. Either way, scientists are sure that at least some pieces of our original galaxy could live on. About 30% of the dead neutron stars in the Milky Way's galactic underworld will eventually be ejected into intergalactic space, flying off to brand new systems. As new research explores these graves in more detail, updated data could begin to alter their perceptions of the initial map. Still, the team is looking forward to seeing what kind of breakthroughs will arise from the dead. Until then, all we can do is speculate about our future and wonder, how long does the Milky Way have? Do we have enough time to ensure the survival of our species? What do you think? Let us know in the comments section below.